Let's start by looking at a few SQL problems that we can solve. And the main goal of this exercise or these problem sets that we're going to do in this video is not to solve or get to the solution as quickly as possible, but to actually understand the thinking process behind how can we approach such a problem in real world. And usually there are several solutions to such problems. If we can understand the problem deep down, what it means, then that's 80% of the solution there. Then the next 20% is actually writing the SQL query. So in these problem sets, we are going to focus at how to approach the problem and how to actually work it out in our heads first before writing any SQL at all. So let's start with this simple problem that I have in front of me. So we have two things over here. So we have a customers table and we have an orders table, right? And let's look at the actual problem that we want to solve. So the problem we are trying to solve is write a solution to find all customers who never ordered anything, right? So that is the key over here. So we want to find all customers who have never ordered anything at all. So if I look at the table again, we have the customers table over here and we have the orders table over here. And our job is to find people who've never ordered anything. So there is also output, a format of the output that we've been given. So this will help us to verify what we are doing is correct or wrong. So let's use that and then try to conceptually understand the problem itself first. So first we have the customers table and we have the orders table, and our job is to find customers who've never ordered anything. So let's do this. Let's start by thinking really small. Imagine we had a few more rows over here with also orders as well, right? So if this is our case, let's find out if Joe has ordered anything. Now, the way to do that is to use like a left join or some other join, but in this case, left join works best. So imagine a customers table is on the left and orders is on the right. So left join will do a job. So first, let's find out is if Joe has ordered anything. So Joe has a customer ID of 1. And if we try to find the same in customer ID over here, 1 exists over here. So there is an order that belongs to Joe. So we can just say it exists. So there is one order. Let's actually put in the order ID. Let's make this order underscore ID and let's give it the order ID of 2. So the order ID is 2 over here. Let's find out if Henry's ordered anything. Henry has a customer ID of 2. Now, Henry does not exist in this table over here. So we can just say Henry does not have any orders. So it is 0, or this would be null, right? Because Henry's order ID does not exist. Next, let's look at Sam, who has a customer ID of 3. Sam does appear in the order table with an order ID of 1. So let's have 1 over here. Next, let's also do Max. So we have 4 customer ID and customer ID does not exist over here. So this will be null as well. So when we do a join, we have this sort of a table. So this is our first step. Now the second step is to actually remove these orders because they already have orders number associated to it. So we just need the null values, which is Henry and Max. That would be our second step. In the first step, we just did all this join. And in the second step, we are doing the filtering, right? And this should help us get to what we have here, which is just Henry and Max. So hopefully that was clear enough to just work things out in our heads first. Now there is also another solution with subqueries, which we'll look at next. So let's run this in BigQuery and see what result we can achieve there by writing actual SQL. So in our head, we've done 80% of the work. Now it's about time to do like 20% of the actual SQL writing. So I've got these queries over here, which will help us create all these tables and put values into them in BigQuery. So we have these 4 tables. Now let's jump into BigQuery and start writing query. Okay, so I've gone ahead and created my customer table and orders table by running these SQL queries, right? So that is already there. So now let's look at writing the actual SQL for this. So let's start by writing a select, and we are interested in mostly the names. So what I can do is I can say c.name as customers. We'll understand where C is coming from in a bit. So next we can write the from statement and then point it to our table, which is customers over here. And let me just give it an alias called C. So now you can see where the c.name is coming from. So we are just picking the customer name over here. So our next step is to do a left join on the customer ID column within the customers table and the orders table. So we'll do a left join SQL.orders. SQL is my dataset name. And then we'll also give it an alias called O over here. And how do we want to join? What columns do we want to join this on? That comes next, where we are saying c.id is equal to o.customer ID. Now, because of these aliases, we are able to clearly identify where the ID is coming from and where the customer ID is coming from as well. So up to this point, what we've done is what we saw initially, where we had another column with all the orders and so on. So next step is we want to filter out these two people and then only be left with Henry and Max. So we can do that easily by adding a where clause, and then I'll just say where o.id is null. So this is what we did initially, where Henry had order ID of null and Max also had order ID of null. And when we run this, we get Max and Henry as our results, which is what we were looking at. So one simple thing I like to do as well is to format the SQL query in such a manner that it's easy for me to read. So I find it usually easy to read when I have everything in one line, or there's like a gap in between the joins and the filtering and so on. Especially when we get to more complicated queries, I feel like it's much more readable for me. So this was the first solution, where we are using the joins to find out who are the customers who haven't ordered anything. Now, there might be an even simpler solution if we go for a subquery. Now, again, if we were to look at my framework or the flowchart that I had defined. So in this case, we looked at joining table over here in our beginners course. And of course, within the intermediate course, we have some advanced querying techniques, which is where we find subqueries and nested queries. So if you've already completed the intermediate section, or if you're already familiar with subqueries, let's think about how we can use this over here. So all we want to do is find the customers who haven't ordered before. So would it not be much easier if we can just get these 3 and 1 user IDs from this table, and then when we are doing filtering, we can just use this in our filter to say, give me all the users who are not in this list. So how this would look like conceptually is we have the select statement, right? And then we have from, and we have a filter. And in this filter, is it possible to give these two values so that we can write where ID is not in this list? In our case, we have 3 and 1. So if we're able to get this list somehow, then we can easily filter out on this table directly and get all the users who are not in this table, which would be Henry and Max. So this is where we get to use subqueries. So to get this 3 and 1, we can just write select customer ID from this table, and we can have this select customer ID from this table. Imagine this is our query, and instead of this, we would just pass this over here. And this would be a simpler solution if you're using subqueries. So let's quickly look at this solution in BigQuery. Let's work on the subquery first and just try to get the customer IDs over here. And an easy way to do that is just to write select customer ID from sql.orders. And if I run this, we get the customer ID 3 and 1. Now we want to pass this into a where clause and put this in a subquery. So if I do this now, we have a subquery, and we can say where ID not in, and then this would be 3 and 1, which is coming over here, and that would be passed in over here as values. So again, to finish this query off, we can have something like this, where we say select name as customers from this table and where ID is not in this, right? So we are filtering out all the users, which in our case is customer ID 3 and 1. Now, if we run this, we have Max and Henry. So we've seen two different solutions and two different approaches to tackle this problem. Now, in most cases, the 80% of the work, like we was about conceptually thinking how we are going to solve this problem, and also not just this problem, how we can generalize it so that when we do get more values in this customers table or orders table, it still works. You don't have to go in and fix your query every time. So that is a quick way of solving these problems, and we look at several other problems as well, and hopefully this will give you a flavor into how to go about tackling these real world problems, which is, think about it, 80% of the time how you're going to solve this first, write it down in a piece of paper if you have to, and then start to write your SQL queries. So next we have another problem. Let's look at this. So we have a country, and it's called as a big country if it has at least an area of 3 square kilometers, or if the population is at least 25 million. Now, in this problem, we need a solution to find the name, population, and area of the big countries, right? So anything that satisfies these two parameters is considered as big, and we need a list of all these big countries. So again, before writing any SQL at all, let's conceptually think about what could be the output result and how to get there. Fortunately, we've been given with output table over here where we have Afghanistan and Algeria as the two countries which are considered as big according to this table, right? So we are going after Afghanistan over here and Algeria, right? So these are the two countries that we need as the output. Now let's conceptually think about how to approach this problem where we need a list of all the big countries. So once we have a list of all the big countries, then picking out the name, population, and area like these columns is quite straightforward. So let's look at this. Afghanistan, does it have an area of at least 3 square kilometers? So we come in here. Actually, it does not. So it does not satisfy this. But let's look at population. Of course, population is greater than 25 million. So we can say that Afghanistan is in our final data set. And Albania, we see it's less than 3 million, less than 25 million. Algeria, again, less than 3 square kilometers area. So this does not qualify. But then we have a population which is greater than 25 million. So this satisfies. So in our problem statement, we have to understand that this is 3 million and we have this or over here, which means that it has to satisfy either of these conditions. And if either of these conditions are satisfied, then we have a big country, right? So instead of or, if the problem statement actually said and, then we would need both area and population to meet these requirements. So reading the problem set again and again while we are conceptually doing this is really beneficial. Now let's look at Andorra. So this does not satisfy in the area or the population. Angola, it doesn't do that either. So we have our final table, which is Afghanistan and Algeria, and it is similar to what we have in our output table down below here as well. So now how to go about getting to this is the second step, which we have to think about in a SQL manner. So is there a way where we can do all of these steps in SQL? And it looks like there is no complex joining or subqueries within here. It has to do with just simple filtering. So can we filter out by looking at two parameters and then giving the SQL these conditions? So we can write a simple where clause, right? So we can have where, and then imagine this is a select statement, this is a from statement, and then we have a filtering where area greater than 3 kilometers, 3 square kilometers, etc., etc. Or, so we can use this Boolean operation or, right? And we can say or population is greater than 25 million, right? So we can have this as our condition. Whichever countries meet these conditions, then we have our final list from here. So this would be a simple query. So let's run this in SQL in BigQuery and see what result we get. Now, let me just copy these two statements over here, which will just allow me to create this in BigQuery. And within BigQuery, I'll just paste them. And first, let's create this. Actually, let me put my dataset name over here. So I've created the world table and let's insert some data into it. And I've inserted some data into it as well. So let's write a SQL query and see what we get. So we start by writing the select clause, and we are interested in three columns: name, population, and area. And we'll give it the name of the table. And actually this has to be SQL dataset.table. And then finally we can define our filter. So when we define our filter, we have this where we have area greater than 3 square kilometers, 3 million square kilometers, and then population is greater than 25 million. And the key over here is this or clause. So we have either this condition or this condition satisfied, then we get the result. So let's run this. And when I run this, we have Afghanistan and Algeria as our results. So let's look at this SQL problem that we have here. So here we have this employee table, and the question is to find a solution where we need to find the managers with at least 5 direct reports. So like I always say, 80% or 70 to 80% of the work is always in conceptualizing how you would go about solving this in real world, and then you write the SQL statement. So let's understand this a bit more and think this through in our heads, or in our case on this screen, and then see what we can write when it comes to SQL. So first of all, we have the question, which is find managers with at least five direct reports. So let's understand this. So we have the employee ID over here, and then the manager ID over here as well. So this shows that these manager IDs are nothing but the ID over here, right? So if we were to take an example of John over here, so we have John who has an ID of 101 but has manager ID of null. So John, we'll presume he is the CEO of a company and there is no manager above him, right? Now let's take an example for Dan. So Dan's employee ID is 102, but then manager ID is 101. So Dan's employee or so Dan's manager is actually John. So we have John over here as the manager of Dan, and Dan is the direct report to John. So that is one of the prerequisite here. Find five direct reports. Now let's check the next row, which is James over here. And James also has a manager ID of 1, which means James again is being managed by John. And James is also a direct report of John as well. So that's how you would go about finding the direct reports. Now, let's also look at a few examples over here where we have Amy. And Amy has a manager ID of 102, which means Amy reports to Dan now, right? And then we have Annie, who has manager ID of 101, which means Annie is reporting to which means Annie is reporting to over here, which is John. Next, we have Ron, who has 102. So 102 is actually Dan. So Ron is reporting over to Dan. Next, we also have Jim, who is reporting to 101, which is John over here. So 101 is over here, right? So you get the idea. So these are all the direct reports. Now, how do we go about finding managers with at least five direct reports? So just by looking at this, so we know that we have 101 and 102. So we have 101 and 102 as the managers. So we can say that we have John and Dan are the managers in this case. So we just have to find the manager with at least five direct reports. So we can see that for the manager IDs over here, so we have 1, 2, 3, 4, and 5, which is for John. So we have 102 and 102 over here, which is for Dan. So straight away by looking at this, we can say that John should be the output, and we also have an output table over here, which is also saying it should be John. So conceptually, how we can approach this is we can do a group by to get all the manager IDs, right? So if we did a group by manager ID, and if we had this output, it will produce 101 and 102. Let's not consider about null for now, so we'll just leave this out. So we have 101 and 102 over here. And let's also get the count. We'll get the name and manager ID, right? So this would be the manager ID. And if we were to also get the name column over here, so this is the manager ID column, and then we have the name. So 101 is John and 102 is Dan. And let's also add another column over here where we get the count of number of users, which would be the direct reports. So if we say count, let's just call count on ID. So we have count, or it could be direct report here as well. So when we say John, we have John, which would produce 5 because we have 1, 2, 3, 4, 5, and Dan, who has 2 people. So Dan is 1 and 2. So this, we would get 2. So again, think about this conceptually. We have to get to this sort of a table where we have the manager ID, name, and the count of people who they are managing. So this would be our first step. Now, once we do have this, then we can apply a simple sort of a where clause on this. So we can say where count is greater than 5 or greater than equal to 5. So this would be our second step. So once we do this, we have only John, which should be returning. So I hope you understood this to how to tackle this conceptually. So we looked at how to figure out the direct reports, and then how to get to count all these users and then get to the output. So we've just done that over here where we've got like an intermediary table and then we filter it out. So this is how you would approach this in a real world. Again, I encourage you to try this on your own and write this out on a piece of paper. See what kind of results you get before you start writing any of these queries at all. Even now, when you saw me write this out, you saw that I started by doing a group by, got just the manager ID column, then realized I also need the names. So I got the names because in here we have to find the managers. So we need the name, like what is shown in this output. Then I added the count because I know if we can get the count, then we can filter it out in the next step and get the output. As you practice more and more, you'll get a hang of this. But yeah, this is how you would see. Now let's see if what the SQL query we wrote, clean this up and write this in BigQuery and try to get this result. So I've got these two SQL queries here, which will help us create the table. So let's copy these now and let me run these as well. Actually, I need to update my data set. Let's also insert data into this. So again, select the relevant query you want to run if you have multiple queries in the box so that BigQuery knows what query to run. So we'll run this and insert data. So we've added 8 rows and that is good. So let's try to run this again, doing this step by step. So I'll first say select manager ID from my employee table. Let's run this. Now we should get all the manager IDs from our table. So that is good. Now let's do a group by. So when I do a group by, we will only get the unique IDs. So we got the unique IDs over here, manager 101, 102, and null exists here as well. Now I can straight away filter on this because if you remember, we also have an SQL statement called having. So I can write having. Now I want to filter out only the managers who have a count greater than 5, which would mean that they have 5 direct reports. So this is how I would do it. I would say having count star greater than equal to 5. So now if I run this, we would only get manager 101. So we've got this. Now all that's remaining is to go back to our original table and use this as a subquery and filter it out. So we would use something like this where ID in this subquery. So the ID we are looking for is 101. And again, we can wrap this with select and from statements like this. So we have the select statement and from statement, and we are getting only the name from the employee table where the ID is present in the subquery, which is 101. So if you run this now, we will get John. So I hope this makes sense. So as usual, go through this in a conceptual manner first, write this out, write some pseudo tables if you have to, in between tables, temporary tables, and then see how you can approach this on a piece of paper and then write the SQL queries. Because once you have the logic down of how you want to approach this problem, then it becomes really easy. And like I always say, there's multiple solutions to one problem like this. So you don't have to look for the optimal or the right solution right away. Figure out the most comfortable statements that you have used, like group by, having some aggregations, and so on. And then see if you're able to solve using those statements. And then you can always look at new statements and new ways of doing this once you find your solution. So next we have another interesting problem that we need to solve using SQL. So let's look at this. So we have this table over here, which has requester ID, acceptor ID, and this is a friends table. So imagine this is Facebook or LinkedIn or any of the popular social platform where someone is sending someone else a request to be their friend, and that someone else accepts or reject that friend request, and there is this friend date or accepted date. So let's look at the question. So we need to write a solution to find the people who have the most friends and the most friends number. So this is just the count, right? So this can just be the count of number of friends. But the key here is find the people who have the most friends. So again, let's look at this in a conceptual way first, understand what would be our train of thought to get to this solution, and let's think about what SQL we can write to convert this conceptual thought into SQL. So first we have all these entries over here and we have all the requester IDs and so on. So these are nothing but the user IDs, right? So we have one user ID, 2, 3, 4, and so on. Now we can also look at the output for a second. So we have the ID number 3 with the number of 3. So this means the person who had the most friends over here was number 3, and how many of those friends did that person have, which is number 3 again. So let's look at this and see how we would solve this in our head. So we have 1 over here and 1 is friend now with number 2. So let's write this down, right? So let's say we have 1, 2, 3, and 4 as our users. And if we say that 1 is over here and 2 is over here, so 1 has one friend and 2 has one friend as well now. So 1 is friends with 3 now. So 1 gets one more friend over here and 3 gets one friend over here. Next, we have 2 who's friend with number 3. So 2 who's friend with number 3. And again, we have 3 who's friend with number 4. So 3 who's friend with number 4. So if you look at this, we clearly have winner who is number 3 with 3 friends. Now this was easy to do this right in our head. So this would how we would do this if we did not have SQL. So all this is showing me that we just need to count the number of friends and then look at the top friend with the most number of friends. Now because we are only interested in the most friends and the number of friends, what I can do is imagine if all this was under here as one big column, right? So imagine if we only had ID and all these things we had over here. So this would be 1, 1, 2, and 3. And then we also had all of this underneath here. So this would be 2, 3, 3, and 4. So these are all the IDs of people who are friends with each other. So we can do a group by on all of this. So we can just do a group by and we should be able to get the values like this. So 1 has 1, 2, 2 count, right? And 2 has, let's put 2 here, let's put 3 and 4. So these are all the user IDs and this is the count. So next, if we look at this, 3 has 1, 2, 3. We have 3 over here. Let's see, 2, 2 has only 1 and 4. Actually, 2 has 1 and 2 over here. So 2 should be 2 here. 3 and 4 is 1. And if we get to this stage, which would be our 1 and 2, like we just saw, this would be our first and second stage. And once we do have this stage, all we need to do is order by, and then we'll order by this count column, and then this would be count column. And we should also use a limit clause as well to just get one person, because the question is what find the people with most friends. So we just want one person who with most friends and the number of friends. So to get to this stage, all we did was we did two operations where we need 1 and 2, which is we can achieve this using union all operator. So again, we don't need union distinct, we need union all. So we just put everything in one single row like this, and then we do a group by and we do a filter on this. So hopefully this makes sense of how to go about from the concept to thinking about how to approach this in an SQL manner. And we haven't even written SQL yet because we already have 80% of the work done as to what operations we'll be using. We'll be using union, we'll be using group by, we'll be using order by and limit as well. So let's go about write this in SQL and see what we get. So I have these two statements over here, which will give us the table we want. And let me change this over to SQL and SQL as well, which is my data set. So if I just select this, BigQuery will only run this query, not this. So I'll just hit run on this. So the table is created. Let's insert data into it. Now the data is inserted as well. So let's start with our SQL query. Let's start with what we wanted, which is the initial table with all the users and the number of friends they have. So let's write the union all. So I'll write union all, and we can also say acceptor ID from the same table. And mind you, we are using this alias as ID over here. So when we're doing union all, we need this common table, common column name between the two union alls. So this should give us all the IDs within the table that we have. So if I expand this out, so these are all the values. So some of them are requester IDs, some of them are acceptor IDs, but then we are only interested in IDs over here. It doesn't matter for us. We'll just wrap this in the from and also write the select clause as well. So we want to do a group by now. So I'll write ID and also I'll put the count as well because we need the count of users. Now you'll straight away see that we have an error saying reference column ID, which is neither grouped nor aggregated. So in BigQuery, it sort of gives you hints as to where you want to go next. Now we need the group by clause next. So next I can just do group by ID and see what values we get. So we have the ID over here and the number of friends each user has. So we see here we have 3 who has the most number of friends. So all that is left to do is order by in descending order and then limiting only the top result. So I can put order by count in descending order, see what this value shows us. So now we have moved the ID 3 with the top number of most number of friends to the top, right? So this is in ascending order. Sorry, this is in descending order where it goes from bigger to smallest. Now all we have to do is we just need this value, right? So we can do a limit of 1 and we would get this result. So when I do limit of 1 and run this, we have the final result, which is also what we were looking at. So again, it's not that complicated. We went from inside out. So we wrote all these things first, which we had conceptually in our mind as well. And then we did a simple group by on all of this. And then we did a limit and we got our result. So next we have another SQL problem, and this I would place it in intermediate to hard level. So if you don't get this in the first run, and if you haven't completed the advanced course, then don't sweat too much. I advise you to look up on the window functions and a bit more complicated problems as well. So having said that, let's jump into this and see what we have. So we have a table over here, which is an employee table and also a department table. And we have a sort of like a output table that's been given to us as well. Let's look at the question and see what we have. So a company's executives are interested in seeing who earns the most money in each of the company's department. So a high earner in a department is an employee who has a salary in the top 3 unique salaries of that department. So there is our first key over here. So we need to find top 3 unique salaries for each department. Next, we have so write a solution to find the employees who are high earners in each of the department. So we need to find the high earners in each of this department. The first step is to understand what it means by high earners. So this should be top 3 unique salaries for that department. So those people are considered high earners. And then we need to find this for each of the departments. So hopefully that makes sense. Now it'll make even more sense once we start to understand this conceptually, or how we would go about doing this on a piece of paper if we did not have SQL. So let's try to do that and see where we get. So the first thing I would do is I would get all the department names as a separate column over here. So we have a new column over here. Let's call this department name, right? And we have the department ID one over here, which is one, which is IT, right? So all the ones would have IT as the department. So this is IT again. This is IT and this is IT as well. Have sales over here and sales over here as well. So these are all the department names that we have. So the next thing we have to do is we need to find the top 3 earners within each of these departments. So the key is in understanding that statement. It says within each department. So window function would be the most efficient way of solving this problem. If we were to think of one window, which is Joe over here, and also includes Max and all these people. So imagine this is our window. We don't need to consider this for the second. And then if we consider this as a window, then we can simply go about adding another column over here, which would be the rank. So let me add another column over here, right? Which would give us the rank within this IT department. So here, if we think about this, and the function that we are looking for is dense underscore rank, because we look at dense rank versus rank in a second as well, but let's go with dense rank first. So if we were to think of this region which we've selected in our window as our partition, now we can order the users or employees within this partition by salary, which would mean that Max over here gets the number 1 rank because Max has the highest salary of everyone in here. And then we have the next salary, which is lower than 90,000, is 85 over here and 85 over here as well. So these two people will get 2, and Randy will get 2 here as well as the rank. And then next we have number 3, which would be 70,000, right? 70,000 would be 3, and then Janet would be number 4, right? So this would be number 4 for this particular window. We have this as our value. So this we get because we are using dense rank. There is also a rank function. What this would do is it would still allow us to rank it the way we've put this in place. So we would get 1, 2, and 2 over here. But then after 2, it will skip the number because we have two repeating two times over here. So this would be, if this is our number one, this would be number two. And because two is appearing twice, then we don't have three, and we directly go to four for this user, and we go to five for this user. So again, that is the rank function. If you want, you can read up on that documentation or watch through my advanced course and learn about this. But for our case, we are happy with dense rank. And then we can pick out the top three over here, which is one, two, and three. And that would be the users we would pick out from this window. We can do the same for this window as well. And we should be able to rank these users as well. So here, Henry would get number one rank, and Sam over here would get number two rank. So this would be our final table over here, where we would get all these two, three, four, and only number four, which is Max, should be missing in our final table. We'll get everyone else. That is a way we would do this in like a piece of paper, or thinking on this in an SQL manner. So let's break this down and then see what we need to do in steps. So the first step, what we would do is this. So we need to join this table, right? So we need to join the department table and the employee table in our first step. And then the second step is actually to define these windows. So we have this window over here, which is covering all of this, and also this window over here. So we need to define the window and what we would give it for partition by clause and order by clause within the window functions. And then finally, we have all these dense rank as well. So dense rank would come in this partition as well. And the final step would be to filter out or limit the number of users, the number of employees to three. So the third step will be just to limit these, let's call this dense rank. So this is dense rank column, which is less than equal to three or something along those lines, which should give us all the users. So that would be a conceptual way of thinking about how to tackle this problem, which is one, two, and three. Now let's create this table in BigQuery and also write the query itself and see how far we get with this. So I have all these queries over here, which will let us create these tables. So let me just copy this, and I'll rename this to my data set name, which is SQL. So let me create the employee table first, and let me insert the values into it. And let me create the department table and also insert values into that. So now we have all the tables created, which is department and employee. Now we should be good to write our SQL. So let's write this query incrementally and see how far we get with it. So first we need the select clause, and we will add the ID and the name of the department. And we are reading all this from the table called department, which is D. So if I run this now, so we have ID2 and department, and ID1 is the IT department. So if you remember, the first operation we wanted to do was the join operation. So let's do that now. So I've just added a few more columns over here and also written join over here on the employee table, which is E. And what are we going to join this on? So we are going to join the department ID with the employee table's department ID. So if you look at here, E is the employee table, and the D over here is coming from this alias, which is the department table. So now when we get this, so if I run this now, so we kind of have the departments, which is sales, and all the employees. So we have all the employees over here. And if you remember, join is just a full outer join, which can also be written as just a join here. So outer join, if you remember, it just gets all the columns from both the tables. And if the value does not exist in the other table, it just puts it as a null value. So in our case, we don't have any null values in either of the tables, so it's fine. But if you wanted to look at another table where we have some null values, then doing a left join or a right join might not work. So we definitely need outer join so that we preserve all the values from the department table and the employee table. So that's a full outer join or just join. So now that we have all these things, so the next step in this case was to assign a rank for all these users by doing a window function, right? So let's write that out and see what result we get. So we are doing a dense rank over here and partitioning by department's ID. Now, at this point, you should be familiar with all these window functions. If you're not, here's a quick summary on it. So dense rank is the aggregate function we are using. So this is similar to sum or count or average or mean. All these functions are aggregate functions. And similarly, dense rank is the one which is available within BigQuery and most of the SQL databases as well, for the window function. And over is just the window that we're defining, and this is just a keyword. And partition by is another keyword, and we give it the partition, how we want to partition this window. So if you remember, in our case, we wanted to partition by the sales department and the IT department. So giving this department.id makes sense over here. And we also want to order the values within this window in a certain fashion. Because we're using rank, we want to rank this in a certain way so that we are getting the person, employee with the most salary at the top of this window. And we do that by defining this order by and salary, and we say we want it to order by in descending order, and we give this column an alias called R and K. So if I run this now, so now you see we have these ranks, which is a dense rank. And if you think about this, so this is our first window, which is on the sales department, and this is ordered by descending order, right? So if we look at the code again of the dense rank, we are saying we want to partition by this department ID, which is over here. And then within the department ID, we want to order salary in descending order, which is happening over here. So this is in descending order. And then we assign it a dense rank value, which is over here 1 and 2, right? So if you think about the next operation, so this would be on all this, because this is our IT window, which is on the ID called number 1, right? And within here as well, we want to order this in descending order, because we've specified we want to order by descending order. And we have our dense rank function as well, which is 1 for max, which is 90,000, and then we have these two values which are same, so they get the same rank 2. And then we have 70,000 for will, and because we are doing a dense rank, we get the number 3, the next consecutive number. If this was just a rank instead of a dense rank, then this would be number 4, right? So that is the difference. Now we don't have to worry too much about rank because we're using dense rank, and this is number 3. And then finally we have Janet, which has been given number 4. So hopefully this window function and this window function over here, dense rank, makes sense, because this is the key in this SQL problem solution. So the next step remaining is to only get all these values, which are the top 3 in our each of these departments, and we don't want this. So how do we go about discarding? So we can just do a where clause or a filter and then get all these values, or we can say only give me all the values where the rank value is less than equal to 3. So we can surround this with the from clause, because this can be a subquery. You can even remove this or put this in a separate CTE, common table expression, if you want. But here this makes a lot much more easier to read. But if it's a more complicated example, then CTE would be fine as well. So now we have department, employee, salary, and everything else. And we say we want to filter these users who have a rank less than 3. And if I run this now, we get all the results that we were looking for. We have all the sales results, Henry and Sam, and all the IT results, who are all the top 3 earners within each of these departments. So hopefully that made sense, and the solution is easy enough to understand. So again, I would say go with the usual joins, group bys, and so on initially. And if you're not able to solve it with those, then go for the aggregation functions, like the window functions. Window functions are very, very powerful, like you just saw, and it can solve a lot more bigger problems, harder problems as well, which we'll look at in the next series of videos.